Okay, systems of linear inequalities, tutorial number 1. Let's go. So today we're going to be graphing linear inequalities. So not systems of linear inequalities, just single linear inequalities. All right, so when we look at number 1, we see we have the equation y, or the inequality, y is greater than or equal to negative 3x plus 4. And we're going to pretend, let's pretend that we're really dealing with the line y equal negative 3x plus 4. Well, we know 4 is our y-intercept, so we put that there. Negative 3 is our slope, so we go down 3 over 1. And then we're going to stop. So we're going to use this to find 2 points. And then we're going to stop. So we're going to find our 2 points, and we're going to stop, and we're going to say, wait a minute, we're not really drawing a line. This isn't an equal sign. It says y is greater than or equal to this line. Now, when we hear ourselves saying greater than or equal to, it does mean that this inequality, this shading we're going to do, is going to include a solid line through these 2 points. Okay, that's a squiggly line, isn't it? So when we see this line underneath the greater than sign, and we hear ourselves saying greater than or equal to, that means the solution that we're about to graph includes the line. So we can use a solid line through the 2 points. All right, we also say y is greater than this line, and it either could be equal to this line or it could be greater than this line. So how are we going to do our shading? What we're going to do is we're going to put our pencil or pen, marker, whatever you're using, exactly on the y-intercept. I don't know if you can see. I'm trying to make the y-intercept bigger. But I'm going to put my point on the y-intercept, and I'm going to say to myself, what's greater than this line? What's greater than this y-intercept looking at the y-axis? Well, if the y-intercept's on 4, then I know going up to 5 and 6 is greater than. So that tells me shade up above the line. So obviously we can't shade all above the line, right? We can't, but that's really, this inequality means this line and everything greater. We could even extend our line and extend our shading to show that. So instead of graphing a line, we are now graphing a linear inequality. All right, so let's do the same thing but with a different problem. First step is going to be, let's pretend that we have a line here. We're going to get our 2 points, and then we're going to stop. We're going to get our y-intercept, which is negative 5. And then we're going to get our slope, which is up 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. Get our 2 points, and then we stop, because we're not really in an equation, are we? Nope. We're in an inequality, and it says y is less than this line. Ooh, can y be equal to the line? Now, y, when we look at equations and inequalities, y is standing for our answer. You know, x is the input, y is the output. So our answer has to be less than the line that we would make if we join these 2 points. So we can't use a solid line this time. We have to use a dashed line or a dotted line, because y is not equal to this line, right? We don't see that line underneath. It's less than this line. So to find out where we should shade, if y is less than this line, I'm going to put my pen or pencil or whatever I have in my hand, I'm going to put the point on the y-intercept, and I'm going to say, what's less than negative 5 on the y-axis? Well, all the numbers going down the y-axis are going to be less than that, which tells me my shading is down from the line. Okay, so hopefully you're catching on that the only new thing about today is deciding whether to use a solid or a dotted line to connect our 2 dots and where to shade. So let's look at this next problem. We've got y is greater than negative 4. Okay, I know what the line negative 4 looks like. I know I go to my y-axis, and I put a dot on the negative 4, and I know that the slope is 0. It's going to be a flat line, but I don't know whether to draw a solid or a dotted. What do you think? That's right, we're going to do a dotted. We see y is greater than the line negative 4. It can't be equal to, so we're going to use dashed or dotted, however we want to say it. And then we'll put our pen or pencil on the y-intercept. It says y is greater than -4. Well, I know all the numbers on the y-axis that are greater than -4 are up. So that means I'm going to shade up. So if somebody looked at this drawing or this sketch, they would see that the answer has to be greater than the line y equals 4, or sorry, y equals -4. So y is greater than -4. All right, let's try another one. X is less than or equal to -5. We know that. The line x equals -5, we go to the x-axis, we put a dot on the -5. We know that x equals a number is a straight up and down line. So can we do a solid line or can we do a dashed? Well, we see that x is less than or equal to. So that, because we see that line, that or equal to line, we know we can make a solid line for our line. Now, remember how I always say for the shading, put your pen or pencil on your y-intercept? Well, there's no y-intercept. So this time, we have to put our pen or pencil on our x-intercept and play the same game. We've got to shade so that x is less than or equal to -5. And I think about, well, if I shade to the right, those numbers are all greater than -5. The numbers that are less than -5 are to the left. So I'm going to shade to the left. All right, so hopefully you're catching on. We're going to get lots of practice with this.